Welcome back, Research Design and Analysis students. In this segment today, we're going to start talking about factorial ANOVAs, and we'll start with the between subjects factorial ANOVA. What a factorial ANOVA is it builds on our previous ANOVA designs to start to use more than one independent variable. And so, our learning objectives are to understand what factorial designs are, including important concepts like factors, levels, and conditions, express factorial designs using factorial notation, identify main effects and interactions based on matrices or tables of means and graphs, complete a summary table for a two-way ANOVA, explain what a two-way ANOVA between subjects is and what it does, and interpret a two-way between subjects ANOVA. We can also do within subjects factorial ANOVAs, which is where we have the same individuals multiple times or have people matched on an important characteristic. Now, what is a factorial design? The primary idea about a factorial ANOVA design is that we're using multiple independent variables at the same time to predict an outcome. In this case, each independent variable is called a factor or treatment. And so if you're remembering what some key terms are from the other ANOVAs we've learned, just doing a one-way ANOVA, between or within, a factor is the word that we use to describe an independent variable. We will also have a dependent variable, sometimes called an outcome, in our study. A level is a particular group or value in the independent variable. So I could have a factor like class year, which would be our factor, and then have 4 different levels: freshman or first years, sophomore, junior, senior. In this case, I'm going to use the color blue to help remind you where we're looking at levels, and red to help you remember where we're looking at factors. Again, factors the major idea or independent variable. Levels are the groups or conditions of layers within that factor. We also use the word condition to specifically talk about an option across all of the levels of the independent variables. So if we have more than one factor, we're going to look across factors and levels to figure out how many conditions or total number of groups we have for our participants within our study. The other thing that we will look at in part 2 of the screencast for Factorial ANOVA is main effects versus interactions. Main effects are considering only one independent variable at a time to figure out if that particular independent variable affects the dependent variable. We can also then look at interactions, which is looking at the combination of several different independent variables to best predict a dependent variable or outcome. If we find an interaction between our independent variables, the picture gets a little bit more complex and we find ourselves saying, well, it depends, when we want to explain what happened in our dependent variable. So, first, in this screencast, a little bit of information about the language of factorial designs. We're going to take first an example where we might ask the research question, what if men and women are affected differently by music on their stress levels? In this case, we will make a test having gender or sex as one independent variable, along with music as a second independent variable. So we have these two independent variables, factor A, music, which we might set up in a basic study as having 2 levels, music or no music, and factor B. Notice factors again are in red, levels are in blue. And for factor B, we might have the factor or independent variable of gender, and perhaps we only have enough males and females to include them in our study. We care about our transgender and gender non-binary folks too, but it's harder to grab a sample of them, so maybe our sample only has 2 gender groups. This would result in 4 conditions in our study, as we combine the 2 factors in order to see people in each of the conditions. So in this particular example, how many dependent variables do we have? 1, just stress level. But we're looking at 2 factors to see if they'll predict those stress level outcomes. Now, we often represent factorial designs with a matrix, a kind of table that looks at these factors in combination. So if we wanted to look at the effects of music and gender on people's stress levels, we will put one of those factors and its levels across the top for the columns. we will put the other factor down the side in its levels so that we can see how these two things might interact, and we'll get a sample of people in each of the groups to give us a total sample size. Notice this is a between subjects design because the people in each of these conditions, each of these boxes is a condition in our study, are going to add up to a grand total of 40 people. If we had a 2 by 3 factorial design, maybe we have a study that has 2 levels of gender for its first factor, and a second factor about music with 3 levels, music, rock, and classical. In this case, we'll need people in each of these conditions, 2 times 3 equals 6 conditions, to get to our total sample size and answer all the questions of our study. If we had a 4 by 3 factorial design, we might ask, for example, how music type and question type affects people's stress levels if they were taking a test. Maybe we have 4 kinds of music that we let them listen to before or during the test, and maybe we have 3 different kinds of tests, multiple choice, short answer, and fill in the blank. And we want to see how that dependent level of variable of stress is affected by each of these outcomes. So again, in a between subjects design, each of these groups of people is unique or independent. We don't have anybody repeating data in this study. Now, again, each factor can be between subjects where each level is independent or non-repeating, or we could have a within subjects model where each level repeats or the people are matched on some important third characteristic. So we could return to our first example about music and gender, and we could have a case if we had a between subjects design where each of these conditions has unique people, or we could do a kind of within subjects design where we have the same individuals complete all of the conditions in our study. In that case, we need much fewer people, but those folks might get tired after doing the 4 conditions of our study. So there are trade-offs about advantages and disadvantages to a between subjects or within subjects design. Here's another example of a 4 by 3 within subjects factorial design, 4 levels of music, 3 different kind of tests that we give them, and we want to see how well they do at getting their final score based on those conditions. But again, each person then within design would be repeating each of the levels and conditions of our study, so that here is where each person of those 10 people is doing all 12 conditions. So they might get kind of worn out by the end. We also can have a mixed factorial design, where we have 1 or more between subjects factors and 1 or more within subjects factor. So if we did this returning to our example of gender and music, gender has to be a between subjects factor because we can't randomly assign or manipulate people to change their gender. However, if all participants are tested both with and then without music, or vice versa, music becomes a repeated measure, also known as a within subjects factor. So here's an example of a mixed factorial design. We would have men and women who first take music and then not music, and we ask them their stress levels. So we have 10 separate men here, 10 separate women here, but then we have the same men repeat our study and the same women repeat our study. So gender is between subjects, music is within, and we only need half the sample size as if we used a completely independent subjects design. Advantages of factorial designs? Well, first off, they give us increased precision and control. We reduce some of the unsystematic variability across individuals, so we get a little more confident that the variables we're looking at are actually leading to some kind of cause or prediction for our dependent variable. It makes a circumstance like gender, which might just be sort of haphazard across our subjects, become an independent variable rather than something random. So this adds some statistical advantage too. With greater control, we have less of that unsystematic variability, and we are more likely to be able to pick up on a real effect. The other thing is we can study interactions. We can look at how those different independent variables relate together or have some kind of pattern in predicting our dependent variable. Right? Maybe men and women, for example, are affected differently by the outcome when we consider a second factor. Now, factorial designs also have their disadvantages. They can be time-consuming and costly. You have to find more participants and measure more levels than if you're just doing a t-test. It can become unmanageable if you try to add too many independent variables. Too expensive, too time-consuming, your participants get too tired. It does take larger samples then to do more of these more complex design to find significant effects and trust that statistics are not just making a type 1 error. So if we assume that you need to have about 20 people in each condition of an ANOVA in order to trust your results as being good enough, you can see how this quickly adds up if you try to add layer upon layer of independent variable. Now, about the ways, this is about the notation for ANOVA. If we have a two-way factorial design instead of a one-way, this means we have ANOVA testing our hypotheses, but we have two independent variables. So each independent variable can have two or more levels. We'll get to levels in a minute. Right? If we had a two-way design, or a 2x2 ANOVA, we would have two independent variables. We've got two numbers indicated here, and that tells us our ANOVA's notation. All right? One factor, two factor, two ways. If we had a three-way design, you'd see it this way. We have three independent variables, each with its own levels, 1, 2, 3 factors. If we had a four-way design, four independent variables, 1, 2, 3, 4. Now, the levels, the value numbers, tell us how many levels in each independent variable. So if we have a 2x2, two-way ANOVA, we have two independent variables, one here and one here. Each one has two levels or conditions in it. If we had a 2x3 ANOVA, still a two-way design with two independent variables, but we have one factor with two levels, and we have a second factor with three levels. Graphically, in a table, this is what it would look like. A 2x2 design, we'd have two levels of factor A up here at the top, two levels of factor B here, 4 conditions total. So if we multiply these numbers together, it will tell us the total number of conditions in our study. And again, we want about 20 people in each condition in an ANOVA to have good confidence in our results. If we were going to report on a 2x2 design in our results section to say how we set our study up, or sometimes in our method section, we would talk about a 2x2 design, and we would help our readers see what the levels or conditions are. So it would be nice if we told them not only the factor, but the levels involved in our design. So sometimes you'll see people just say a 2x2 was used. Other times we'll say the data were analyzed using a 2x2 ANOVA. All right, here's an example of a 2x3 design. Gender has 2 levels. Music has 3 levels. So we have 6 conditions in our study. And similarly to our last example, here are the ways that we might report what our design was if we're writing it up for a research manuscript or a class report. If we had a 3-way design, we have 3 independent variables. Factor A has 2 levels. Factor B has 2 levels. Factor C has 3 levels. 1, 2, 3. 2x4. Right, here's how we would describe it. Again, talking about the factors and the levels, and the idea that we're using an ANOVA. All right, here's closing us out with a 5-way design. If you grew up in the Midwest, you're familiar with Gold Star chili or Skyline chili, where this is often talked about as a 5-way. Yes, it's odd for some other people, but in the Midwest, you might take your chili, and each factor has 2 levels. You start with chili. Are you going to have it or not? Then we add in spaghetti. You going to have that or not? How about onions? Yes or no? How about cheese? Yes or no? How about beans? Yes or no? So if you get chili 5 ways, you are actually looking at 5 independent factors on your meal. Okay? And we could practice with Papa's Perfect Pizza. I'm running out of time, but you want to look at this example and think about how many factors there are, how many levels, And then we could look at our dependent variable for ratings.